Hi students, welcome to Max Point of View. Today we are going to understand the concept of characteristics of sound and their subjective and objective nature. This is part C of the main chapter sound. Here we are going to understand the concept. After understanding it properly, we are going to solve each and every theory question which is there in your textbook, and that video link is available in the description box. Not only that, all the videos of all the chapters links are available in the description box. So without wasting any time, we'll move on to the concept. When it comes to sound, till now we have learned many processes, many examples, so many things we have learned. But when it comes to part C, this chapter is very easy. This is just about characteristics of sound. So this is one of the easiest chapter in your physics textbook. So this is but here one definite question you can get in the exam, and those questions will be very simple, just if you with the common sense and proper knowledge. Okay, many students will get confused with what are characteristics and what are the factors. So if you don't have this confusion, you can aramse answer any question. So this much and few more things, that is it. Okay, and many things from part C has been omitted. Those are not there for the syllabus. Many students will be thinking, oh, we have so many things. Those logarithm equations are also there. Though we don't know how we are going to study. All those things are not there. So focus on the video. Now in this video, whatever we are going to learn, only that much is there in the syllabus. Now first we learn about the characteristics of sound. So here characteristics are very simple. Loudness, that is one characteristic. There are actually three characteristics, only three. Keep this in mind. Only how many characteristics? Only three. Okay, loudness is one characteristic. Pitch is the second characteristic. Pitch has one more name, that is nothing but shrillness. Okay, pitch or shrillness, we can use any one in the exam. If they use any one of these, you should be able to analyze both are same. Next, quality is one of the characteristics. This is the third characteristic. It has one more name, that is timbre. So timbre means quality means timbre. So any one word they can use in the exam, you should not get confused. So now these characteristics will get affected from few factors. Okay, characteristics are different, factors are different. This is the main part. Okay, for this main part, which factor will affect them? Okay, which factor will affect them? When it comes to factors, we talk about factors affecting the characteristics. Affecting is not like causing the harm. Okay, it is not going to trouble this loudness. Affecting means it can increase this value or decrease this value. That's it. Affecting means it can increase or decrease the characteristics. Now what is the factor which affect loudness? Main factor is amplitude. Then pitch or shrillness, that is frequency. Okay, when it comes to amplitude, okay, amplitude is the factor which affects loudness. But when it comes to it is not just amplitude, it is amplitude square. Okay, amplitude square is directly proportional. Okay, how it is proportional? Directly proportional. Frequency is also directly proportional, and quality or timbre, this depends upon waveform. What type of waveform we are going to get? Okay, listen, see, these are the factors which will affect these characteristics. So students should not get confused with the factors and characteristics. Characteristics are only three: loudness, pitch and quality. Factors are, there are many factors, but these are the main factors which will affect these characteristics. Amplitude square, how it is affecting? Loudness is directly proportional to amplitude square. That means, see, I'll give you an example. If amplitude, if the value of amplitude is 2, assume amplitude value is 2, then loudness will be 2 square, correct? Because amplitude square is loudness. So if amplitude is 2 square, that will be 4. Okay, then if the amplitude is increases twice, okay, it is increased twice, that means initial amplitude value is 2, Okay, now it becomes 4 because it is increased twice. Then what will be the loudness? See, apply the value here. Now the value is 4. 4 square, L will be 16. Loudness will be 16. So, if the amplitude increases 2 times, okay, 2 times, loudness increases 4 times. Loudness increases 4 times, 2 square. If the amplitude increases 3 times, okay, loudness increases 3 square, that is 9 times. So in this way you need to understand. So whenever you get some doubts, okay, rewatch it, you will definitely understand. And in the same way, if the amplitude decreases 2 times, okay, loudness decreases 4 times. If the amplitude decreases 3 times, okay, then loudness decreases 9 times, 3 square. So how much it is increasing, in the same way it will also decreases. Some of the questions you may get in the theory solution, if the amplitude is half of this original value, then loudness will decreases by 4 times, or you can write it as 1/4 of the initial loudness. So these are the tricks you need to know. Okay, so loudness, see which is a factor affects loudness, okay, that is amplitude. How it is affecting, if they are asking how it is affecting, directly proportional. We know what is directly proportional. Directly proportional means if amplitude increases, loudness also increases, but how many times increases, that is based on the calculation. Next, we'll talk about frequency. Frequency is the factor, it is not the characteristics. Characteristic is pitch. So pitch is the characteristic, it is getting affected by frequency. So frequency is a factor which affects the pitch. So how it is affecting? Directly proportional. Directly proportional. So here how much frequency increases, that much pitch also increases, pitch or shrillness. But when it comes to amplitude, if amplitude increases 2 times, loudness increases 4 times, 2 square. Okay, that's it. Next, quality. So quality depends upon what? This is the factor which affects quality, that is waveform. But there is no relation between, we cannot say how it is related, whether it is directly proportional or inversely proportional, because this is waveform is nothing but the diagram. Okay, different waveforms. Okay, listen, I'll give you one example. This is the normal wave, correct? Normal wave we talk about. When it comes to quality and timbre, okay, mainly, okay, it is about different waveforms like this. Okay, so quality depends upon the type of waveform. We cannot say it is whether it is inversely proportional or directly proportional. So these are the characteristics and these are the main factors which affects them. Next, we'll talk about few words. Okay, listen, whenever we use these kind of words in the exam or in the theory solution, you should not get confused. Faint sound. Faint sound means a very low intense sound. Very low intense sound. I'll give you one example. Assume there is a person here, okay, he talks. Whenever he speaks, the sound will travel, and one more person is here, okay, he is going to hear the sound. Okay, but here, whenever the distance is more, we know the loudness decreases. The loudness decreases, correct? At the end, okay, assume the sound is going to stop somewhere here. Okay, after crossing this point, the sound will not travel. Assume that point, sound will be damped vibration, completely ends. Okay, after reaching that point, it will not hear. Before that, very low intense sound we are going to hear, right? So if the person is shouting, okay, I'm standing here, I'm shouting, the person is, one more person is standing too far. Do you think that the person who is standing away from me hears the same intense whenever he is near to me? No, right? It has, the intensity has to be, the loudness has to be will be very low. So that is nothing but faint sound. It is almost going to die. Almost going to die. Okay, next, that is the meaning of faint sound. Next, feeble sound. Feeble sound means soft sound. Soft sound. So it is not harsh, it is soft, like it is a soothing sound. Okay, we can call it as soothing sound also. So faint sound means the sound which has very low intensity. Okay, it is almost going to die. Okay, next, feeble sound means soft sound or soothing sound. So these are some important things about the characteristics of sound. Now we learn some more things about loudness. We learned amplitude is the factor which affects the loudness, correct? So amplitude is not the only factor which affects loudness. There are many factors. Okay, these are the factors which affects loudness. Now here we learned amplitude square, everything about amplitude square, how it is going to affect the loudness, correct? Now we'll move on to the remaining things. Surface area of the vibrating body. If the surface area of the vibrating body is more, loudness will also be more. I know you did not understand anything, very simple. Okay, you take a tuning fork, okay, hit on the rubber pad and hear the sound, you will hear a humming sound, correct? Now again you repeat the same experiment, hit the tuning fork with the rubber pad and keep it on the table, now you will hear a loud sound. Why? Because the surface area is more. Now the surface area, okay, of the vibrating body is more. Then density of the medium, okay, it is not the density of the object. Okay, if you are talking about guitar, sitar or piano or flute, it is not the density of the material, it is the density of the medium. If I am talking here, the medium is air. If I am talking in water, the medium is water. Okay, the medium, air, water, solid or vacuum. In vacuum we cannot hear sound. So only three mediums are solid, liquid and gas, correct? So density of the medium is also important. More the density, more will be the loudness. More the density, more will be the loudness. Next, presence of resonant body. What is resonance? That we have learnt in part B, correct? So resonance is very important topic, keep this in mind. One definite question in the board exam, you analyze the previous year papers, okay? So one definite questions in the board exam based on the resonance. So we have learnt everything about resonance in part B. Now if the resonance is present, okay, near any sound, okay, assume there is a sound and there is a resonant body near to it, okay, then loudness will be more. Next, this is the only factor which is inversely proportional to loudness. What is that? The square of distance between the source and the listener. Okay, assume I am the source because I am talking, right? I am producing sound, someone is listening there. Okay, what is the distance between me and the listener? If the distance is more, loudness will keep on decreasing, correct? As he goes away, the loudness decreases, correct? So it is the square of distance between the source and the listener. So these are the factors. What is the only factor which is inversely proportional to loudness? That is square of distance between the source and the listener. So these are the factors which affects loudness. Now we learn everything about intensity. See, intensity and loudness are related, but they are not same. Keep this in mind. Intensity is different, loudness is different. How it is different, that is what we are going to learn now. So definition, first we learn the definition of intensity. It is the amount of sound energy passing per second normally through a unit area at a particular point. At any point, at any given point, it is the amount of sound energy passing per second. Okay, passing per second in a unit area. So it is amount of sound energy, correct? Sound energy, and they are talking about time, E by T and per unit area, correct? So E by T, energy by time, is nothing but power, correct? So it is almost like power divided by area, correct? Because amount of sound energy per second, energy by time, okay, power is equal to energy by time, correct? So energy by time, instead of taking energy by time, we can also say power divided by area, unit area. Okay, so when it comes to this definition, how can we derive the unit? We got to know it is power by area. What is unit of power? That is watt. Okay, area, we know it is power divided by area, so it is meter square, watt per meter square. That's it. Next, so this is the definition, this is the unit. Then ordinary sound. What will be the intensity of ordinary sound for a normal person? Okay, it is the ordinary sound, intensity of ordinary sound is 10 power minus 6 Weber per meter square. These are some facts. Okay, next, minimum intensity which we can hear, that is 10 power minus 12 Weber per meter square. This is the intensity of an ordinary sound. This is the minimum intensity which we can hear. Okay, below this one we cannot hear. Next, 10 power minus 13 we cannot hear. Next, factors. Okay, which are the factors which will affect intensity? As I told you earlier, intensity and loudness are okay related but not same. So intensity is directly proportional to amplitude square. Like loudness, intensity is also directly proportional to amplitude square. In the same way, intensity is also related to frequency. Do you think loudness is related to frequency? No, loudness related to amplitude square, but intensity is related both to amplitude square as well as frequency square. Next, intensity is directly proportional to the density of the medium. Next, intensity is directly proportional to the velocity of the sound. So the definition, unit, some facts, these are the factors. We know everything about intensity. I told you loudness and intensity are related but not same, correct? This is the proof. See, loudness is subjective in nature. Subjective in nature. Intensity is objective in nature. What do you mean by this? Very simple. Object. Okay, objective in nature means it depends upon the object which is creating the sound. Object is which is creating the sound. Here, I am the person who is creating the sound. So, I am the object. Okay, object. So, intensity we can calculate. Whenever sound comes out of my mouth, I can calculate the intensity. Okay, I can calculate the intensity. But I told you loudness depends upon the person. Okay, subjective in nature means loudness depends upon the person who is listening. Okay, intensity related to the person or a object which is creating a sound. Loudness depends upon the person who is listening to the sound. So the person's intensity, okay, loudness, the same sound, okay, for two different people, loudness will be different, correct? It depends upon their sensitivity of their hearing. So loudness cannot be calculated because loudness for a person, okay, it is not fixed. Loudness for two different people, it is not same, so it cannot be fixed for two different people. So loudness depends upon the listener. Okay, that is nothing but subjective in nature. Intensity depends upon the object. So you can easily calculate the intensity of the sound. Okay, but when it comes to loudness, as loudness depends upon the sensitivity of the listener. So loudness is subjective in nature. It depends upon the listener. Intensity is objective in nature. It is from the source. It is from the source which can easily, intensity of the sound which can easily calculated, but loudness differ from person to person. Then the relation between loudness and intensity. See this relation. Okay, there are three equations, okay, three relations when it comes to loudness and intensity. All these relations, their derivation, their use, nothing is there in the syllabus, so no need to study this one. Okay, there are like this, there are two more equations. Based on that, no questions will be asked, no numericals will be asked. So this relation between intensity and the loudness is not there in the syllabus. But how which is subjective in nature and which is objective in nature is very much important. Now we'll talk about pitch. So if we know this much about pitch, that means we have learned everything. So when it comes to characteristics of sound, loudness, pitch, quality, the definitions are not important, don't worry about it. So the important things are, there are many things about apart from the definition, but intensity definition is important. Okay, so when it comes to pitch, quality and loudness, these things, the factors and important notes, all those things are important. Now listen, what is the only factor which affects pitch? That is frequency. Frequency is the only factor which affects the pitch, and frequency will get changed by other factors. Okay, and we should know how frequency is related to pitch. It is directly proportional. If frequency increases, pitch also increases. How much frequency increases, that much pitch also increases. But when it comes to loudness and amplitude, loudness was directly proportional to amplitude square. So if amplitude increases 2 times, loudness increases 4 times. If amplitude increases 3 times, loudness increases 9 times, 3 square. But when it comes to pitch and frequency, how much frequency increases, that much pitch also increases. Keep this in mind. Next, so acute note. So these are the few words which we are going to use. Okay, acute note or shrill note. Okay, what do you mean by that? That means high pitch sound. High pitch sound. If it is high pitch, the frequency is also high. Keep this in mind. So acute note means acute note or shrill note, because in the exam they are not going to give you directly high pitch sound, all those things. They are going to use these kind of words, but we should know the meaning of it. Okay, acute note or shrill note. Okay, acute note or shrill note is nothing but high pitch sounds. Okay, high pitch sound. Flat note or grave note. Flat note or grave note is nothing but low pitch sound. Low pitch sound. Now these are the words. So this is very much important, because in the exam they are going to confuse you with these words only. But if you have the knowledge, then whatever the confusion they are going to make, you will not get confused. Now next, pitch is mainly about musical sounds. Okay, it is mainly about the musical sound. So it is with reference to the music. Next, flute. So here these are the important things about the pitch. Okay, listen. When it comes to flute, so assume this is a flute. I know this is not a proper diagram. Assume it is. Assume, we can assume anything, right? So assume this is a flute and these are the holes on the flute. Now, one thing before learning about the flute, we need to know frequency is inversely proportional to length of air column. Length of air column. Length of air column means how much air column is left, how much air column is there. Okay, the length of air column. So which I am going to teach you here. Don't worry about length of air column, but only thing you should know is these two are inversely proportional. More the length of air column, less will be the frequency. More the length of air column, less will be the frequency. That you should know. Now listen here, when it comes to flute, when you close the holes, when you close the top holes, okay, not these two holes, okay, the front one and the back one, no, not this one, the top side. Okay, whenever we talk about holes of a flute, we don't talk about this part and this part. Okay, we talk about these holes on the flute. Okay, so when you close this one, when you close the hole, the length of air column inside it becomes more. Okay, when you close it, keep this in mind. When you close it, okay, the length of air column becomes more. Keep this in mind. If the length of air column is more, frequency will be less. If the frequency is less, pitch will also be less. So it is low pitch note. So this is how it is important. So these kind of questions you can expect. If you close the holes of the flute, whether you are going to hear a low pitch sound or high pitch sound. So pitch and holes of the flute are in, so they are not directly related. So when you close the holes, the length of air column increases. Because this is increasing, frequency reduces. Because of frequency reduces, pitch also reduces. This is how you have to analyze. Okay, so if the holes, if you close the hole, the air, okay, air inside it, okay, it will get a proper channel. Okay, it will be in a proper channel when you close it. See, if you close the first two holes, the length of air column will be till here. Okay, if you close the first one and third one, the length of air column will be from this point to this point, and from the second one to third one. This will not be considered as from first to second we did not close, second one we did not close, right? So from first to second, the length of air column will not be considered. So assume first three we have closed, the length of air column will be from this point to third hole. Okay, like that you need to understand. So only important thing here is, if you close the hole, okay, length of air column increases. Length of air column increases. If that increases, frequency reduces. If frequency reduces, pitch also reduces. So if you close the holes of a flute, it is a low pitch. If the holes are not closed, it is a high pitch. Okay, assume there is a scenario. There are two flutes. Okay, one person has closed two or three holes. Okay, person A has closed three holes on the flute. The same flute, okay, the same flute is held by another person B. He has closed only one hole. Okay, only one hole, which has low pitch and which has high pitch. These are the questions you can expect. More the person has closed more holes, right? So length of air column is more. If the length of air column is more, frequency is less, so it is a low pitch. More the holes are closed, it is a low pitch. Less the holes are closed by a person B, it is a high pitch sound. This is how you should compare. Next, string. Well, now we'll talk about string instruments. Okay, guitar, sitar, sonometer, all those things are string instrument, even the piano. Now listen, tension. There are two factors which will affect the frequency. Tension of the wire, thickness of the wire. What do you mean by tension? Tension is nothing but how tightly you have connected it. More the tightness, more it is tight, more will be the tension. Okay, more will be the tension. If tension is more, frequency will be also be more. So tension, okay, is directly proportional to frequency. Directly proportional to frequency. So if the tension is more, frequency is also more. What do you mean by tension? Tightness, how tight it is connected between the two knobs. Okay. Next, thickness. Okay, thickness is inversely proportional. Thickness is inversely proportional to frequency. That means if the thickness is more, frequency will be less. Inversely proportional. So that means thinner wires will have high pitch sound. Thinner wires will have high pitch sound because thinner the wire, frequency will be more. Thickness is less. Correct. Thinner wire means thickness is less. So frequency will be more. If frequency is more, pitch will be more. So high pitch sound. Thinner the wire, high pitch sound. Thicker the wire, low pitch sound. And more the tension, more will be the frequency. So these are the tricks you should know. Next, water and air level. In 2025 paper, because of this question, okay, because of these two words, many students lost 80 on 80. They got 79 because of these two words. So length of air column is inversely proportional to frequency, that we know. So that is the same air level, or air level is nothing but air column. Okay, so the question, this is assertion and reasoning question, which was asked in 2025. They were talking about water column. Many students thought about air column. So they thought water column is nothing but air column. No, listen, I'll give you an example. Assume this is a water can and assume it is completely empty. Now if it is empty, the length of air column is from here to here, from the top to bottom, because air is there. Complete from top to bottom, air is there when it is empty. Whenever you fill water till here, so the length of air column will be from the top till here. That's it. This will be the water column. This is the length of water column, and this is the top position is length of air column. So you have to be very careful. So here, whenever that is the reason, whenever the water is filling up, you will hear a high pitch sound, so that we can easily say the water is about to fill without seeing that. How we can say? As the length of air column decreases, frequency increases. As the water is getting filled, okay, length of air column keeps on reducing. If length of air column is reduced, frequency will be more. If the frequency is more, pitch will be more. That is how, without seeing the water level, we can easily say water is all about to fill the bottle. So these are the tricks you should know. So next, and water level is inversely proportional to air level. Keep this in mind. Length of water column is inversely proportional to length of air column. More the water column, less will be the air column. Keep this in mind. Next, woman's voice. Woman's voice is usually a high pitch sound compared to men's voice. Okay, there is a very simple reason. Okay, first, the woman's vocal cord, okay, the length of woman's vocal cord is less than the length of men's vocal cord. So we know, so more the length, more will be the length air column. Correct. More the length, more will be the air column. Correct. So if the length of air column is more, then frequency will be less. So that's why in men the vocal cord length is more, and thicker. Okay, not only the length, it is about the thickness also. So that is why our sound is different from their sound. Okay, length of vocal cord, ours is more and thicker, and the women's vocal cord is the length of vocal cord is less and thinner. That is why they have high pitch sound compared to vocal cord length is also very much important. Next, subjective and objective in nature. So when it comes to subjective and objective, we have some simple knowledge, correct? Based on the loudness and intensity, we have used subjective and objective in nature, correct? So frequency is objective in nature. So frequency, keep this in mind, frequency objective, okay, and pitch is subjective. Keep this in mind. Okay, so frequency depends upon the source, okay, the sound, the source which is producing the sound. Pitch depends upon the person, it depends upon the person. So frequency is nothing to do with the listener, it is mainly depends upon the source. Okay, so for frequency can be aram se calculated. This is one proof that frequency and pitch are related, but they are not same, they are not same. So pitch depends upon the person, but pitch for same sound, okay, frequency will be same, for the same sound frequency will be same, but pitch will be different, because pitch depends upon the person, different person. Okay, different person, pitch will, for them different pitch will be there based on the sensitivity. So these are the important things. If you know this much about pitch, then you know everything. Any logical question you can answer based on the pitch. Now we'll talk about quality. So this is our final characteristics. So this is very easy. If you know this much, that is enough. Definition is not required. Now listen, when it comes to quality, which is the only factor which affects quality, that is waveform. Waveform. But when it comes to waveform, there is no direct or inverse relationship. Okay, based on waveform we can say based on the waveform we can identify the quality. That's it, there is no direct or inverse relationship. Now tuning fork and other instruments. Tuning fork and other instruments. When it comes to tuning fork, keep this in mind, tuning fork will always give us monotone. It is of pure note. So what is monotone? The same frequency. If the complete every vibration will have same frequency. Pure note, that is the same thing. Monotone, pure note will have same frequency. That means frequency produced by the tuning fork is always the same. So whenever they talk about monotone or pure note, okay, it is always about the tuning fork. Keep this in mind. So all the waves will have same frequency. See this one, see this is from the tuning fork, this is from the other musical instrument. See the complete, okay, every wave will be similar, same. Okay, next when it comes to string instrument, see the wave, that's it. So whenever we talk about quality, I told you waveform. Based on the waveform, see if the waveforms are different, then that means it is this question is related to the quality. That is how you should know. Okay, if this is like this simple, okay, it is not related to quality. If the any waveform apart from sinusoidal, this is called as sinusoidal waveform. Sinusoidal waveform, sine waves. Okay, sine waves, and these apart from this one, any different shape, that question is related to quality. Next, amplitude and frequency. Two sounds will have same amplitude, same frequency, but they differ in quality. See like this, based on the waveform. See, I'll give you one example. Same amplitude, same frequency, they'll differ from quality. I'll give you one example. See, for 1 second it has produced two waves. In the same way, different sound, two different sounds. See, they have same height, correct? Same height. Assume that they have same height. That means they have same amplitude. For 1 second, they have produced, both the sounds have produced two vibrations. So even though they have same amplitude, they have same frequency, they differ in quality because they based on their waveforms. Next, recognition of sound. This is very much important and Simple question. This is what we are learning from 7th grade, correct? When it comes to quality, this is the characteristic of sound. Okay, we can recognize someone's voice over the phone, correct? We can easily say, without saving their number, assume your father or mother is calling you from a different mobile number, someone's mobile number. Immediately when we hear their voice, we can easily say this is our dad or mom, correct? Based on what? That is based on quality. Okay, so quality is the important keyword. So if they create question like this, then the answer will be quality. And in the same way, whenever we get to know someone is playing piano, okay, and we don't see them, we never saw them playing that, so just we are passing like that, and because of the sound, we can easily say this sound is coming from piano, not from the flute. By how we are telling all those things? Because of the quality. Okay, based on the quality, recognition of the sound is there. So whenever recognizing a sound, type of sound questions are asked, it is completely related to quality. So you have to say because of the quality. That's it. Now we'll talk about our final topic, that is music and noise. First we'll learn everything about music, then we'll go for noise. Listen, so if you know this much, that is enough. Music is a pleasant, continuous and uniform waves. So it has, the definition is not important. Understand, you can form a sentence and that will be the definition. Music is a pleasant, continuous and uniform sound wave. That's it. So understand this one by looking at the waveform. Listen, these two waveforms are related to music. Okay, so it is pleasant, continuous and uniform. Listen, these waves, okay, these are from this one, tuning fork. When it comes to other musical instrument, listen, there is a pattern. See the pattern, it's going up, two up, again a dip, and it is forming the same shape again and again. So these two are related to music. See, it is continuous and uniform. There is a pattern. If you see a particular pattern in a waveform, that means it is related to music. It is not related to noise. When it comes to noise, okay, here see, there is no proper pattern, correct? Irregularly it is forming a wave. Then it is related to noise. So noise, how can we define it? Pleasant, it is unpleasant, discontinuous and non-uniform waves. That's it. And there is no sharp difference between music and noise. Okay, it is again subjective in nature. Some sound may be music for me and maybe noise for you. Okay, like a pop song. Okay, for a younger generation, pop song, okay, they'll dance for it, correct? That is a music for them. For older generation, it's a noise. Okay, so music and noise, there is no sharp difference, but it is different for different people. Keep this in mind. Now we'll talk about the difference between music and noise. First, you can say go for definitions. See, when it comes to differences, maximum marks it can be allotted for this one is 2. Okay, most of the time the difference between any two physical quantities will be asked for 1 mark. Maximum is 2, but most of the time it is just asked for 1 mark. So any one you can write, but you should know everything, because these are not only meant for differences. Based on this one, they can create questions, right? So you have to be ready with everything, learn everything, whatever the question they ask, okay, you can easily answer. So first you can write the definition. Next, sound in music are periodic and they are regular. Periodic and regular, they are not periodic and irregular. Next, sound level. Sound level is from 10 to 30 decibels. Here it is above 120 decibels. See, here many students will make a mistake here. Decibel is not the unit of loudness. It is not the unit of loudness. Decibel is unit of sound level. Sound level is different, loudness is different. Okay, so decibel is a unit of sound level. Okay, for loudness, unit is phon, phon, phon. So plural form phons. That's it. Okay, so your phon is a unit of this one, loudness. Decibel is a unit of sound level. Keep this in mind. Then you can give some examples for musical instruments. Okay, then for noise, sound of an aeroplane, sound of a machine in industries. Those you can take an example for noise. That's it. Now we have learned everything about characteristics of sound and their subjective and objective nature. After this, immediately go for the theory solution, because till now we have learned the complete concept, but we don't know what kind of questions they are going to ask. So my suggestion is, immediately after the concept video, go for the theory. So learn everything. Then you will get the 80 to 90% of the knowledge. Remaining 10%, okay, the same questions we cannot expect from the textbook in the board exam, correct? So they are going to create some questions. For that, you need to know what kind of questions they are going to create. That you can get it in previous year paper. Those videos, those solutions, previous year solution will not be like a complete paper. Only from sound chapter, what are the previous year questions you can expect. So chapter wise, so that it will be easy for you to understand and analyze. So now we have learned everything. After this one, go for theory. After that, go for previous year paper. After that, also for to boost your knowledge, we have created logical and application questions. That is also chapter wise. Finally, it is about MCQs. MCQs also there. All these things are chapter wise, and all these things are available in the description box. Thank you.